Good evening, Nithiran and Pritika.
Sir?
Yeah, I told good evening.
Yes, sir.
Good evening.
Yeah. So we'll get started. This is the current electricity paper. Drift velocity of electrons due to whom? So it is because of the motion of conduction electrons due to the electric field E. Second, direction of conventional current is, it is in the direction in which the positive charges move. Though we have negative charges present inside the conductor, whatever is the direction in which the positive charge is assumed to be moved will be the direction of conventional current. Next. So if there is a wire of resistivity rho that is stretched to double its length, then the new resistivity will be. What is the answer for? A wire of resistivity. So it will not change because resistivity does not depend on length. It does not depend on dimension. It depends only on the nature of the material. So potential difference of 10 volt is applied across a conductor of resistance 1 kilo ohm. Find the number of electrons flowing through the conductor in 5 minutes. So I is equal to V is equal to IR. I is how much? V by R. So 10 divided by 10 power 3. That will be 10 power minus 2. So 10 power minus 2 ampere. Right? N into E divided by T. Sorry, capital N into E divided by T is equal to 10 power minus 2. Which implies capital N is equal to T is how much? 5 minutes means it is 600 seconds into 10 power minus 2. 300. So 300 into 10 power minus 2 divided by 1.6 into 10 power minus 19. So that will give you the required answer. So the answer is 1.875 into 10 power 19 electrons. Okay. The plot of the variation of potential difference across combination of 3 identical cells in series versus current is shown here. What are the EMF and internal resistance of the cell? So the plot varies across 3 identical cells in series versus current is shown here. So potential difference is 6 volt. So when 3 identical cells are connected in series, what will be the net EMF? 3 E. So 3E is equal to 6, which implies E is equal to 2 volt. So the EMF is 2 volt. So across a 2 volt, how much current is flowing is what is the question. If you look at this point, no, this is 0, 6. What is this point? It is 1, 0. Okay. Then EMF is 2 volt means how much current is flowing through them? 1 ampere of current is flowing there. So can I say E is equal to I into R? So 2 will be equal to 1 into R, which implies R will be equal to 2 ohm. So the internal resistance is 2 ohm and the potential difference is 2 ohm. That's what is given. Voltage doesn't? Why? Terminal voltage. Current changes, it changes. EMF will not change. Voltage will change. Terminal potential difference is dependent on the current. So that's why the graph is. Okay. So given the resistance is 1 ohm, 2 ohm and 3 ohm, how will you combine them to get an equivalent resistance of 11 by 3 and 11 by 5? So 11 by 3 is 3 point something. 11 by 5 is 2 point something. Remember, whenever you want the output value to be greater than all the 3 resistors that you are using, you need to connect them in series. When you want the value to be less than or the least resistance that is there in the combination, then you need to connect them in parallel. But if you want somewhere intermediate, then you need to have a mixed combination. Now, in this scenario, if you see what is going to happen. So 2 and 3 are in series. Sir. So 2 and 3 in parallel because, okay, and you want me to connect it. R1, R2 divided by R1 plus R2, no? Or 6 by 5. So this will be for the second case. 1 and 3 should be in 1 and 3 1 and 2 should be in parallel. See, it's very simple. You have the denominator, no? When you connect them in parallel, what happens when you connect 2 resistors in parallel? What happens to the denominator? It will be R1 plus R2. So since it is 3 there, adding these 2 values will you get 3? Obviously 1 and 2. So 1 and 2 should be in parallel and that should be in series with this. So R1 R2 divided by R1 plus R2 plus 3, which will give you 11 by 3. Is that clear? Seventh one. The length and radii of 3 wires of same metal means density, resistivity is constant. Okay. Are in the ratio 2 is to 3 is to 4 and 3 is to 4 is to 5 respectively. They are joined in parallel and included in a circuit having 5 ampere current. Find the current in each wire. So R is equal to R1 will be equal to rho into 2 by 3. 2 by 9. R2 will be rho into 3 by 16. R3 will be equal to rho into 4 divided by 25. All the 3 are connected in parallel. So they are joined parallel and included in a circuit having 5 ampere current. And the current to each resistor is. Solve it. So when they say they are connected in parallel, what is constant? Voltage. So I1 is to I2 is to I3. Can I say it is equal to 1 by R1 is to 1 by R2 is to 1 by R3? So this will be equal to 9 by 2 plus 16 by 3 plus 25 by 4. Can I do this? Sorry, it's 2. Any doubt in this? So what will the ratio come out to be? 2, 3, 4. So 6 into 4, 24 were there. So 24 now, or 12 will work. Huh? So 12 now, how much are you getting? 54 is 2. How did you get 54? 9 into 12 on the 54. 108. Okay. So 108 is 2. Other 12 that I'm multiplying everything with 12. I'm multiplying everything with 12 so that the denominator will cancel it. Okay. But you will have a common multiple, no? Common factor among all the three. So that's what I do. How do you get it 54 here? Means you should multiply with 6. No? Oh, you took, okay. Then it will be 54 is 2. So you multiply 16 into 4 is 64. 16 into, you will multiply with 12. But the 3 in the denominator will cancel that 12 4 times. So 16 into 4 is 64. Is to 25 into 3, 75. So 54 is to 64 is to 75. That is what is I1 is to I2 is to I3. Correct? So sum of all the currents should be equal to how much? No, sum of all the currents will not be 5. Yeah, sorry. Sum of all the currents should be 5, but they want the value of each current. So I1 will be equal to the total current into 54 divided by sum of all the three. That is 54 plus 64 plus 75. So how much? So the answer, I'm not sure how much it's given as 1.4 and I2 is 1.66 and I3 is 1.94. If you add all the three, you should get 5. This is the value. So I2, how will you find it? 64, 5 into 64 divided by sum of all the currents. That's where you have to find this. 12 by 1 minute. How much? 12? .062 into 5. But 0.31 the number. Actually, 5 into 54 numerator. Correct? Divided by 193, which is 1.3. This is what we will get. 5 into 54 divided by 193. So there is a dry cell of EMF 1.6 volt, an internal resistance of 0.1 ohm. They are connected to a resistor of resistance R ohm. If the current drawn from a cell is 2 ampere, then the voltage drop across the resistor capital R. So what is the given data? EMF is 1.6 volt. Internal resistance is 0.1 ohm. Is connected to a resistance of value capital R. The current drawn from the cell is 2 ampere. Current is drawn when the cell is getting discharged. Okay, what is the voltage drop across the resistor? So V is equal to E minus IR. So E is 1.6 minus I is 2 into R is 0.1. So 1.6 minus 0.2. 1.4 volt is the, because they both are connected parallel. Correct, Ada? This is cell with internal resistance is connected across an external resistance. So whatever the potential difference occurring across the ends of the cell will be the same potential difference across the resistance R. Correct? This 1.4 volt. What is the energy dissipation in the resistor? P square by R. Actually, they should have put energy dissipation. It should have been in terms of rate. That is what they should have asked. I wrote it as V square by R because they didn't give the time. And that is the reason I wrote it as. Question is wrong actually. They should have given that value. If they want energy dissipation, they should have asked. They should have given the time. But in solution, see what they have done is rate of energy dissipation. That is perfect. Question is wrong actually. They should have asked what is the energy dissipation rate. This should have been the question. So there is a battery of EMF 3 volt and internal resistance R, which is connected in series with resistor of 55 ohm through an ammeter of resistance 1 ohm. The ammeter reads 50. The circuit diagram. Oh, ammeter reads 50. The circuit diagram and calculate the value of smaller. So draw the circuit diagram and calculate the value of smaller. Can you draw the circuit diagram? Let me see. Read the question carefully. So there is a battery of EMF 3 volt. So first draw the battery with internal resistance small r. It is connected in series with resistor of 55 ohm through an ammeter, which shows a reading of 50 ampere. Actually, I think there is a small problem with the question. 50 ampere is too much current because it is 50 milliampere. Okay. I should give marks for this question, or else mistake should have happened when it was copied from paper to the software. 50 milliampere is the right option. So current is 50 milliampere because they can only for galvanometer they'll give the 50, 60 because those are the number of divisions. Here they should give the unit. Okay, so how will it look like? There is a cell with internal resistance. This is 3 volt. This is ammeter's resistance is 1 ohm. It is smaller. So since it is with an internal resistance, draw it like this. Connect it across an ammeter, and you have a resistor capital R, that is which is 55 ohm. 50 milliampere and resistance is 1 ohm. Okay, this is the circuit diagram. Calculate the value of smaller. Simple Ohm's law. Calculate the net EMF is 3 is equal to net resistance how much? 55 plus 1. So 56. So V is equal to I into R. R is 56. I is how much? 50. Sorry. 3 is equal to 56 plus R into 50 into 10 power minus 3. Okay, so solving this, you should get the answer. So you will get 3000 divided by 50. Cancel this, it goes 600 times. Is equal to 56 plus R. R will be equal to 600 minus 56. This is also very high value. Four ohm. That is more than the external resistance. 4 ohm is the right answer. Okay. Next is there is a 20-volt battery of internal resistance 1 ohm is connected to 3 coils of resistance 12 ohm, 6 ohm and 4 ohm in parallel. A resistor of 5 ohm and a reverse battery of EMF response 8 volt and internal resistance 2 ohm are shown in the figure. Calculate the current in each resistor and the terminal potential difference across each battery. So since more than one battery is there, but this is a simple circuit, we can solve it using Ohm's law. So first calculate the equivalent resistance here with this, and this. And both the cells, how are they connected? They both are connected in series, but in opposite direction. Very clear. You need to subtract the values. So the net EMF will not be 28, it will be 12. So net EMF will be 12 volt. Find the equivalent resistance and you will get the total current. Can you do it fast? Need the values. Huh? 10 is what? Correct. Equivalent resistance R dash is equal to 10 ohm. Okay, accepted. Total resistance. So 12 divided by 10, that is 1.2 ampere. Out of the 1.2 ampere, except the parallel combination. So here 1.2 will get split. So 1.2 will get split in the ratio of what? 12, 6 and 4 are there. So 1.2 into 12 divided by 22. Okay, we can actually do it in another way. Instead of taking the split, you know this current through the whole combination is 1.2. So what is the potential? 1.2. Yeah? So potential. So what will be the potential difference across the whole combination? V is equal to 1.2 into the equivalent resistance here is how much? 2. So that will be 2.4. So 2.4 is the potential difference across all the resistors. So I across 12 will be how much? 2.4 divided by 12. That is 0.2. Adhe mari current across the 6 ohm will be 2.4 divided by 6. That is 0.4. And current across the 4 ohm will be 2.4 divided by 4, which is 0.6. So this is how it is. So these are the 3 current values. Sum of all the 3 will give you 1.2 only. Did you understand what I did? So whenever you have this parallel combination, if you know the current through them, find the potential difference across the whole combination. Then potential difference divided by individual resistance will give you individual currents. One by 12 plus 2 by 12 plus 3 by 12. How much is it? 6 by 12, 1 by 6. Up to 2 then. 2 ohm is the potential resistance. 1.2 is the total current through the circuit. Current to resistance. 1 point total current. I put an arrow mark. I didn't have space there. Clear, no? So 11th one, two cells of EMF E1 and E2 have their internal resistances R1 and R2 respectively. Deduce an expression for the equivalent EMF and internal resistance of the parallel combination when they are connected across an external resistance R. Assume that the two cells are supporting each other. Supporting in the sense negative of the first is connected to the positive of the second. So two cells have their internal reduce an expression for the equivalent EMF. They're connected in series then. Parallel, you should get E by R equivalent is equal to E1 by R1 plus E2 by R2. Do you remember the derivation? Video is there, clear cut up photo to so there is a video in the pre-recorded videos to paper. There I put a separate video on that itself. You go through, you will understand. Sorry. In case of two cells, in case the two cells are identical, each of EMF 5 volt and internal resistance R is equal to 1. Calculate the voltage across the external resistance capital R. So what will be the equivalent value? E equivalent divided by R equivalent is 1 is equal to E1 by R1 plus E1 by R1, that is 5. So the equivalent EMF is going to be 5 volt. Did you understand what I did? I just applied that formula. E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2. E equivalent is what we need to find. R equivalent 1, because both are identical resistors. If identical resistors are connected in parallel, the value will become R by N, which is 1, that is equal to 5 by 2 plus 5 by 2, which will give you a 5. So E equivalent is equal to 5 volts. So voltage across, what is the 10 ohm resistor? Voltage across the 10 ohm resistor should also be 5 only. So this is EMF, sorry, they're asking the potential difference. Upper equivalent resistor will be, equivalent cell will be 5 volt with 1 ohm, which is connected across a resistor of 10 ohm. Are you guys able to understand this? So what I did is, both the cells I replaced with an equivalent EMF of 5 volt. And both the internal resistances were replaced with 1 ohm. E1 by R. That will happen only when they are in series. That is why I wrote this formula. E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2. They are in parallel. So E equivalent divided by R equivalent is equal to 5 by 2 plus 5 by 2, which is 5. Now what is going to be the current? I will be equal to 2 FD1. 5 by 11. And they want the voltage across the external resistance R. So V is equal to E minus IR. E 5 minus I is 5 by 11 into R is 10. So 55 minus 50 divided by 11, that is going to be 5 by 11. So it is 5 by 11 volt that is going to occur across the ends, the terminals of the 10 ohm resistor. 5 by 11 or 50 by 11. my mistake. There's a terminal potential difference across the cell. Sorry about it. No, they mentioned what is across the external resistance. So V is equal to IR. So I is 5 by 11 into resistance 50 by 11 volt. புரியுதாடா? So it is 50 by 11 volt, that is answer. Those who are online are able to understand.
Yes, sir.
Yeah. So 12th one. In a part of the circuit shown in the figure, the rate of heat dissipation in 4 ohm resistor is 100 joule per second. So power is 100 watt. And resistance given is 4 ohm. Calculate the heat dissipated in 3 resistors in the 3 resistors in 10 seconds. So they have given the power across this thing, no? So power will be equal to I square R. I square R, I square R is 100. I square into R is 4, that is 100. So I square evlo? That is 25. I will be 5. So 5 ampere of current is flowing through this device. I is the current through the 4 ohm resistor. So you can calculate the potential difference. Yeah, 5 by 10. Same 5, no, why are you adding them? And how will you say it is 10? Oh, okay. That is what I was about to suggest. What I told is find the individual potential difference. Individual potential difference will be 20 and 10. So the total potential difference is 30. So 30 nale here it will be 10. That is right. Now you can calculate the heat across each device. So heat across the 4 ohm is how much? I square RT. So 25 into 4 into 10. So 1000 joules. Heat across the 2 ohm is how much? 25 into 2 into 10, which will be 500 joule. Heat across the 3 ohm will be 1000 into 3 into 10, which will be 100. Okay. So it will be 100 now, just 3000. Is that right? I hope it's clear. Yes. 13th one. 2 cells of EMF 1.5 volt and 2 volt and internal resistance 1 ohm and 2 ohm respectively are connected in parallel so as to send current in the same direction through an external resistance of 5 ohm. Same as previous problem, right? Draw the circuit diagram. 1.5, 1, 2, 2. This is connected across a 5 ohm. That is a circuit diagram. So put a box around it. Put a box around it. Using Kirchhoff's law, calculate the current through each branch in the circuit. So they want us to use Kirchhoff's law. Can you find the current in each branch? Can you do it fast? So let's label them A, B, C, D, E, F. If you take the loop A, B, D, E, A, you will get one equation. If you take the loop F, C, D, E, F, you will get another loop. From there, find the current. then add them, you get the total current. So to calculate the potential difference across 5 ohm resistor, you need the current across the 5 ohm resistor and multiply it with 5. That will give you the answer. First of all, huh? 1.5 by 6 Indian theory. I don't know. The answers are given in terms of fraction. But you know how to do, no? Seventeen by 10. 17 by 10 into 5. So 17 by 5. 17 by 10 into 2. That is 17 by. So I hope you all got it, no? Or you didn't get it? Okay. But you will get 3 values, no? See, this is I1, this is I2, this will be I1 plus I2. Take a loop and then do it. No, if you take the loop A, B, D, E, A, then what will you get? A to B when you're moving from high to low, minus 1.5 minus I1 plus I1 plus I2 into 5 is equal to 0. minus 1 point. Current is flowing in this direction. When you're walking in the direction opposite to current, it is increasing. Current in the direction of when you're going from D to E, you're walking in the direction opposite to current. Minus 1.5 plus 4I1 plus 5I2 is equal to 0. So this is linear equation in two variables. One. Similarly, if you take the loop FCDEF, what will you get? Minus 2 minus 2I2 plus 5 into I1 plus I2 is equal to 0. Solve that, you will get the answer. Okay, you will get another linear equation. I1, I2 andro. So they ask the potential difference across 5 ohm. So I1 plus I2 into 5 multiply. So you need I1, I2, find it out and do it. That part I'm leaving it to you. Is this the equation that you got? Shall I proceed? So 14th one, using Kirchhoff's law, calculate the current in the arm AC of the given circuit diagram. AC enga irukka? On what principle does the meter bridge work? You guys can do this sort of. Panam dima takkana equation mattum eludunga. So if I take the loop EFCAE, E to F, I get minus 30I plus 40 when in doubt na how I1 I2 are there. That is what I was wondering. This I na eduthukalanda. Minus illada plus low to high. Minus 40I is equal to 0. Correct? Similarly, if you take the loop ACDBA, when you're going from A to C, 40I plus 40. Correct now, plus 20 I2 minus 80 is equal to 0. Okay. But so we need to find this I. So on the I you need I1 and I2 first. So take the third loop, you will have 3 unknowns, 3 equations solved for it. But equation of the other one, you have to write it as I1 plus I2. You can write. You would write it as I1 plus I2. So you'll have 2 linear equations in 2 variables. I hope that part you can do it now. So I1 and I2 is what you will get. I1 plus I2 is what the current that is flowing across AC. So yeah, on what principle does a meter bridge work? Obviously Kirchhoff's law. Why are the metal strips used? So as to reduce resistance. Okay. So thick metal strips are used to minimize the resistance of the connection wires because the connection resistance have not. So generally when you take the formula, right, you don't take the connection resistance into consideration at all. So to reduce that only, use thick copper strips at the end. So that's it. State Kirchhoff's rules for an electric network. Using Kirchhoff's rules, obtain the balance condition in terms of resistance for the 4 arms of a meter bridge. You can do this. There's a theory question, right? In the meter bridge experimental setup shown in the figure, the null point D is obtained at a distance of 40 centimeters from the end of the meter bridge wire. The resistance of 10 ohm is connected in series with R1. R1. Null point is obtained at 60 centimeters. Calculate the value of R1 and R2. So before the series resistor, R1 by R2 will be equal to how much? 40 by 60 or 4 by 6 or 2 by 3. This one. Similarly, R1 plus 10 divided by R2 is how much? 6 by 4. That is 3 by 2. R2 can I write it as 3? R2 can I write it as 3 by 2 R1? So R1 plus 10 into 3 R1 by 2 is equal to 3 by 2, which implies 2 R1 plus 20 is equal to 9 R1. So 7 R1 is 20, R1 will be 20 by 7. Am I right? 9. Here 2. In the 2 the mala poiduche. Oh, 9 R1 by 2. Then I'll make it 4 here. Then 5 R1 will be equal to 40. R1 is 8. So R1 is 8 ohm. R2 you can substitute it here. 8 put an ohm. R2 will be 12. And then answer. Where is it? R1 is 8. R2 is 12. All of them. That's it, no? So it was easy only, except those cells in series and parallel you need to practice. So the only concept from which I didn't test is what happens when resistors, what happens to power when the resistors are connected in series and parallel. That part I didn't test. Apart from that, we did everything. But that problem covered, no, that power problem where we had to calculate individually. So we didn't go with formula, we went with basic Ohm's law. So this is all about this paper. Right, I hope it's clear, no? So moving charges and magnetism alone is left. After that, we can go to the 8th chapter. Moving charges, magnetism, we'll do on Monday. Okay. And remaining parts will go. Tuesday will start the 8th chapter. By next Wednesday, it will be done. So next Wednesday, volume 1 will be electromagnetic waves. It's just 2 classes. Okay. That's it, no? We'll wind up. Bye.
Thank you, sir.